Okay, we'll be starting on the YTSS Prelim 2014 for pure physics. So this paper for paper 1 is pretty easy. The tough questions are all on paper 2. So on average, I think you should be able to get I would say high B if you are just studying the textbook, but with a little bit of practice on your TYS, I think you should be able to get an A without much trouble. Okay, let's begin. MCQ first. Okay, question 1 is on your measuration. So this one is basically content based lah. As long as you have read the chapter, you should know that a quantity consists of a numerical magnitude, basically is like just numbers, and a direction. For secondary school, this could just be a positive or negative sign. Okay, then for question 2, what you need to know is that one period constitutes of swinging to the right and then comes back, goes to the extreme and come back again. So it's 1, 2, 3, 4, 5. This will be one period. And once you have that understanding, you just need to do it carefully with the number of swings, you'll be able to get the answer. Okay, for question 3, the reading of micrometer, if you are still having problem, please do read about it on your textbook on zero error. So what you need to take note here is that when you look at this, you don't even see a 0 on the main spindle. Okay, so normally a micrometer screw gauge, one that is without zero error, you would be seeing something like that. Okay, you will see a 0 here. Okay, meaning that on the main spindle, you would have a 0 indicating that it is starting at 0.00. Okay, but in this case, the 0 is actually being so-called eaten up by the thimble. Okay, so what happened is that you would know that, okay, your final answer, you need to plus that bit of difference here. So what you see here is that you read from here is 0, 1, 2, 3. So it's 0.03. You need to add 0.03 to this reading, and so it is option B. If you are still having problem understanding, you can approach me, then I will show you the actual micrometer and then you can understand it easily. Okay, for this case, you have a trolley running down a slope from rest, and in the first 3 seconds you have 3.2. What is the constant acceleration? Okay, the thing here is that what this question is trying to identify is students who use speed equals to distance over time. Okay, if you use this formula, you get the wrong answer. The reason why is that this formula only applies to constant speed. But in this case, the question already hint to you that there is an acceleration. So you cannot use this formula to get the acceleration, or you want to apply it to find the speed. Okay, what some students do is that they use this. They take 3.2 divided by 3 and they take this speed as the final speed. So they use this final speed minus the initial speed over the time, trying to find the acceleration, but it will give you the wrong answer. Okay, because this formula is only applicable to constant speed, meaning the acceleration has to be 0. So you cannot use this. What you can do is that you can sketch a velocity time graph. So you know that at time equals to 3, your velocity is an unknown. You do not know what is this. Okay, so it's a question mark. But do not panic. Okay, do not panic. Okay, keep on doing it. So you know that it starts from 0, 0 and it reaches certain speed at time equals to 0. What you know is that, okay, after 3 seconds it has traveled 3.2, meaning that the area underneath is 3.2 meter. Okay, so just do a quick one. So the area underneath the triangle is half base times the height. Now since we do not know what is this velocity, we will just denote it by V, and the area underneath the line must be equals to 3.2. So this way you will be able to find the V, which is actually 3.2 divided by 3 divided by 0.5. You will get 2.133 something. So you know that at this point, this will be 3, 2.133. And so since you are asked to find the acceleration, and acceleration is basically the gradient of this, so find the gradient, okay, which is your 2.1333 minus 0 minus 0. Okay, once you have that, you'll be able to get the answer, which is 0.71. So this thing equals to 0.71 meter per second squared. So is your option C. That's how you do it. Okay? So please remember that this formula is only for constant speed. Okay? If the speed is no longer constant, you have to rely on sketching a simple velocity time graph. And whenever you do not have certain information, do not panic, just denote it by algebra. Okay? And then solve accordingly. Remember that the gradient of VT graph is acceleration, area underneath it is displacement, or you can say distance. Okay, so since in this case it is above the time axis, it is distance. Okay, question 5, speed time graph again. What is the acceleration at 30 seconds? Again, this is testing you whether you know that the gradient of a speed time graph will give you an acceleration. So at t equals to 30, you would notice that it is actually at the turning point of the curve. And if you remember from your mathematics lesson, at the turning point, the gradient is always equals to 0. So since gradient is acceleration, acceleration will be 0. Okay.